Welcome to the second topic of Module 7, Firearms and Tool Mark Examinations. We will begin by defining firearms and tool marks. We will then discuss the various methods of rifling a barrel for a firearm. We will also discuss the various components of a cartridge and also a shot shell. We will then discuss the individual and class characteristics that are used for firearm examinations. Also, the database NIMBIN that is used in firearms examinations. Then we will begin a short discussion on tool marks, discussing the working actions of tools that create the actual tool marks, and then the class and individual characteristics that are used in tool mark examinations. So if we begin, firearms identification is actually a form of tool mark identification. And this is because a tool mark is considered any impression, cut, gouge, or abrasion caused by a tool coming in contact with another object. For firearms, the firearm itself acts as the tool. The impressions can be made because a firearm is harder than ammunition, so it's going to leave an impressed or striated mark on the various ammunition components as they come in contact. Studies have shown that no two firearms, even those with the same make and model, will produce the same unique markings on fired bullets and cartridge cases. So exactly why is this possible? And this depends on the type of firearm itself. There are two main types of firearms, those that are rifled and those that are smooth. Rifled firearms can be divided into three categories, either handguns, long guns, or machine guns and submachine guns. Handguns are firearms that are designed to be fired using one hand. So this slide contains several examples of a handgun, either a revolver, self-loading pistol, or single-shot pistols. There are also long guns that are rifled, and these are designed to be fired with using two hands. This slide also contains several examples of long guns. And then the final gun that is considered a rifled gun is a machine gun and a submachine gun. These are fully automatic. As long as that trigger is depressed, it's going to continue to fire. So what actually is a rifled firearm? During the manufacturing process of a rifled firearm, the barrel itself goes through a rifling process. This creates the unique spiral, lands, and grooves that the firearm examiner uses in their identifications. So a rifling pattern is going to be created by the grooves that are cut into the barrel itself, and they're usually formed in a spiral nature lengthwise down the entire barrel of that firearm. The raised portion of the rifling is called lands, where the recessed portion are called grooves. Keep in mind, this is as you're looking down the barrel of a weapon. So when looking at a bullet, if you're describing the lands and grooves, they're going to be opposite. The lands will be the raised areas, and the grooves will be the recessed areas. The distance measured between opposing lands and grooves for rifled weapons is called caliber. This is how various rifled firearms are categorized. It is the actual size of that rifled firearm. Essentially, the caliber is the diameter of the inside of that rifled barrel. Firearms can be manufactured with any number of lands and grooves in their barrels, and they can also either spiral to the left or to the right. So a few of the more common rifling patterns are shown in this slide. And you can see from this slide how the barrel would actually appear and then how the bullets themselves would appear. The rifling is what imparts a spin to the bullet as it passes through the barrel. This spin helps stabilize that bullet in flight. Rifling of a barrel can be produced through several different methods. The most common methods used are either broaching, button rifling, hammer forging, or electrochemical etching. With broaching, the barrel itself begins by being completely drilled out smooth. This will remove any minor indentions in that barrel itself. Then, once that barrel is smooth, a broach is forced through the barrel itself. And that broach itself is going to have several successive cutters in the broach. So this is going to cut a little bit deeper and deeper as it goes through that barrel. Button rifling is done in a similar method, but obviously the instrument is a little bit different. Once again, that barrel is drilled out and then reamed to remove any of the drill marks. Then the button is actually forced through the barrel, which engraves the desired rifling pattern into the barrel itself. Some weapons may be rifled through hammer forging. This also begins with the barrel being drilled out, but then the hammer forging unit is actually put inside of the barrel itself, and the barrel is then hammered to create the pattern. The final method is electrochemical etching, and this is the newest method that has been developed for rifling. Once that barrel has been drilled out, the interior is coated with a chemically resistant polymer. The layers of the polymer are going to correspond to the lands of the rifling. A chemical etching solution is then added into the barrel and electric charge is applied. This causes the metal to be eaten away where there is no no protective polymer coating. There are also firearms that have smooth barrels, and these are referred to as shotguns. Just like rifled firearms, shotguns are also classified, but they use the term gauge instead of caliber. So gauge is the number of solid spheres of a diameter equal to the inside diameter of that barrel that could be produced from a pound of lead. The ammunition is chosen according to the actual firearm. Rifled firearms use cartridges, while shotguns use shotgun shells. Each of these are also going to be chosen according to the specific caliber or gauge of that particular firearm. So if we talk about what consists or what components are in a modern cartridge, this slide shows you how more or less a cartridge is put together. It contains several different portions, many of which can actually be analyzed. It primarily contains the bullet or the projectile, the casing which holds all the parts together. It's also going to contain a propellant, which is the powder, a rim, which is the portion of the casing used for loading, and then the primer, which ignites the propellant. There are a lot of various manufacturers that also produce numerous cartridges that can work in the same caliber firearm. In addition to the different varieties, they can also produce varieties within that caliber. So for instance, for a .32 caliber firearm, Smith & Wesson manufactures .32s. A modern shotgun shell also consists of several components. It consists of the
shot, which is the projectile, the casing, which holds all of the parts together. It also has a wad which separates the shot from the propellant, then the brass head, and also the primer which ignites the propellant. Firearms evidence can be recovered in a wide variety of different types of crimes. So it's important to understand exactly how we obtained that firearms evidence. If we think of the specific actions that occur as a weapon is fired, initially the cartridge is going to enter the chamber. A firing pin strikes the primer of the cartridge case, igniting it. The spark from the primer will then ignite the propellant, which causes burning gases from the propellant to expand the cartridge case to seal it against the chamber wall. The gases also push the projectile in the direction that helps release the pressure, sending it down the barrel itself. As the projectile leaves the barrel, the pressure is released, allowing the cartridge case to be removed from the chamber itself. All of these various actions cause unique impressions or markings on the bullet and also on the cartridge case, which allows that firearms examiner to use for the identifications. These tool markings, the various markings caused by the actions of the bullets and the cartridges, allow that firearms examiner to associate bullets and cartridges with specific weapons. So initially, how do we detect firearms evidence? Usually it's going to be through a very good visual search using bright light and oblique lighting, in some instances magnification, but usually firearms evidence is going to be fairly large, so that it is fairly easy to be seen. You always need to remember to document your evidence either in notes and photographs, giving the description of the location, the condition of the item, also identifying the item, and specifically recording that chain of custody. You always want to collect your evidence using the most direct but least intrusive method. And remember, with firearms evidence, it is very necessary to obtain the firearm itself and also the ammunition used for your known samples. You should always have proper packaging and storage for firearms evidence, as well as other forensic evidence. With firearms evidence, it's very important to make sure that the firearm is unloaded, especially if it's going to be transported. However, you should document the location of all of the present cartridges in that weapon before unloading it. The items should be packaged very carefully, especially if it is spent projectile, or spent cartridges, so that you can protect those impressions or striations on the actual evidence itself. Make sure that if you're able to obtain ammunition, that you obtain an adequate supply of this ammunition. And of course, always remember to attach biohazard or warning labels when necessary. Remember, during your storage, you should always be aware of that chain of custody, documenting the chain of custody, and to make sure that the items are properly sealed. Let's take a short break before we continue our discussion on firearm and tool mark examinations.